Now, earlier, when we were noticing that order matters in arithmetic, we noticed that sometimes it doesn't. We noticed that when we have something like 2 times 3 times 5, we can work that out as 2 times 3 and then multiply that by 5, or we can work out 3 times 5 first and then multiply that by 2. And we get the same result either way. Or if we have something like 1 plus 4 plus 7, I can work out 1 plus 4 first, and then add 5 plus 7. Or I can work out 4 plus 7 first, and then add 1 to that. And again, I get the same thing. This fact, that I can do the first multiplication first or the second multiplication first, is called the associative property of multiplication. And the fact that I can do the first addition first or the second addition first is called the associative property of addition. Think associative is like associate, to form groups. Now we can picture the associative property of addition on a number line like this. When we look at this addition, we can think of either first combining the first two vectors and then adding on the last, or first combining the second two vectors and adding that onto the first. Either way, we end up in the same place. For multiplication, it's a little harder to see because it's a little bit harder to envision what happens when we're multiplying three numbers together. But we can imagine 2 times 3 times 5 as describing the volume of this box. And so we can think of taking the volume by looking at 5 sheets of 6 blocks each, or by looking at layers that are 1 block thick and each contain 15 blocks. And then we have 2 layers like that. So, in a sense, the associative property for multiplication consists of exactly how you choose to slice your box up in figuring out its volume. Note that subtraction and division are not associative. For example, if we have 8 minus 3 minus 2, right, that's 8 plus negative 3 plus negative 2. Right, now this is associative. I could add together the negative 3 and negative 2 first if I'd like. But that's different from 8 minus 3 minus 2, right? Because that's 8 plus the opposite of 3 plus negative 2, right? So that's 8 plus negative 1. This would be, if I decided to put my parentheses here, 8 plus negative 5. The key idea is it matters what you're taking the opposite of. Division similarly. 12 divided by 4 divided by 3, that's 12 times 1/4 times 1/3. Right, which is different from 12 divided by 4 divided by 3 in parentheses. Right, this is 12 divided by, well, 4 divided by 3 is 4/3. Right, this will be 12 times 1/12, whereas this will be 12 times 3/4. Right, again, it matters also what exactly you're taking the reciprocal of. All right, now here's another sense in which order sometimes doesn't matter. Let's say we take 6 times 4, right, that's 24. But 4 times 6 is also 24. Or if we take 3 plus 2, that's 5. 2 plus 3, that's also 5. This is called the commutative property. In particular, this first one is the commutative property of multiplication, And the second one is the commutative property of addition. Now, just like the associative property, we can picture these in terms of our models of addition and multiplication. 6 times 4 is the area of this rectangle, while 4 times 6 is the area of this rectangle. Notice that these rectangles are really just the same rectangle with one of them turned sideways. The size doesn't change when you turn it sideways, so we would expect these to be equal. Similarly, we can think of 2 plus 3 as a length of 2 followed by a length of 3. On the other hand, we can think of 3 plus 2 as a length of 3 followed by a length of 2. As you can see, these are going to be the same because it kind of doesn't matter what order we count in. So, in terms of the picture, we would expect multiplication to be commutative. We would also expect addition to be commutative. Note again, subtraction and division don't have these properties. So if we take 6 minus 4, that'll be 6 plus negative 4, right? Which, that's commutative. We could write it as negative 4 plus 6, okay. But that is different from 4 minus 6, which would be 4 plus negative 6. And similarly, 10 divided by 5, that's 10 times 1/5. This multiplication is commutative, so this is 1/5 times 10, no problem. But that is different from 5 divided by 10, which would be 5 times 1/10. Definitely different. In fact, when we work these out, we see that we get positive 2 here and negative 2 here. And when we work out the multiplications, we see that we get 2 here and 1/2 here. If we get the order wrong in subtraction, we get the opposite of what we wanted. If we get the order wrong in division, we get the reciprocal of what we wanted. We will see reasons for that later on. Now, the last important property that numbers have in arithmetic comes when you want to combine multiplication with addition. Now, normally when you combine multiplication with addition, you do multiplication first. So if we have, for example, 3 times 4 plus 5, we'll work out 3 times 4 is 12, add in the 5 and it's 17. No problem. If we want the addition to come first, we use parentheses. 3 times 4 plus 5 is different from 3 times 4 plus 5. This will be 3 times 4 plus 5 is 9, which is 27. But what could we do if we wanted to eliminate these parentheses? Well, let's think about this in terms of our picture of multiplication. Here's a picture of the arithmetic we're doing. We're finding the area of this rectangle that's 3 high and 4 plus 5 on the other side. Look what happens, though, if we draw this separation. Then the area of this rectangle is 3 times 4, and the area of this rectangle is 3 times 5. So 3 times 4 plus 5 can be understood as 3 times 4 plus 3 times 5. Notice what happened here. The 3 was what we call distributed across the parentheses. This is called the distributive property. And the distributive property applies when multiplication and addition are mixed in this specific way. Now, the distributive property works no matter which side the multiplication is on. And that's easy to see because multiplication is commutative. We could get either one of these statements from the other just by swapping orders around. The distributive property also works when it's subtraction rather than addition inside the parentheses. And we can see that if we rewrite the subtraction as adding the opposite. For example, say we want to take 7 times 8 minus 3. That'll be 7 times 8 plus negative 3. Now the 7 is distributed. We'll have 7 times 8 plus 7 times negative 3. Right, well that'll be 7 times 8 plus the opposite of 7 times 3. Note, this just means the whole thing will be negative, which is 7 times 8 minus 7 times 3. Typically, we will shortcut this whole process and just write 7 times 8 minus 3 is 7 times 8 minus 7 times 3. So subtraction works exactly the same as addition with the distributive property. What about division? Division inherits a distributive property from multiplication in cases like this. Say we have 6 plus 8 divided by 2. Right, that's 6 plus 8 times the reciprocal of 2, which is a half. Now we can distribute. That's 6 times a half plus 8 times a half, right, which is 6 divided by 2 plus 8 divided by 2. So in the case of a sum divided by something, division inherits a distributive property from multiplication. And again, just like for subtraction, we can see it by rewriting the division as multiplication.